of f of xy equals natural log of x squared plus y squared in the direction of the vector 1, negative 4 at the point negative 2, comma 3. So this is the two variable case. We have z equals f of xy, and so we're asking for essentially the slope of the surface above this point and in the direction of this vector. Recall the one variable case, if we have y equals f of x, we might have a similar question, find the derivative of f of x, and we would just say at the point some xy. So at x equals a and the y is f of a. So you could either just say at x equals a or at a comma f of a. So notice here they're not giving us the z coordinate of the point. That's kind of like here not giving the y coordinate of the point. It's just not necessary. If you have the x coordinate, you can get the y coordinate. And here, if you have the x and y coordinates, you can get the z coordinate. The z coordinate, for example, would be f of negative 2, comma 3. And that would be the natural log of 4 plus 9, squaring negative 2 and 3. And so that's the log of 13. So that's the z coordinate. So find the derivative of y equals f of x at x equals a. You have the x-axis, and a is there somewhere. And then you have the curve, y equals f of x. And above this point, you have a tangent line. And the derivative is the slope. Now, when you're talking about the x-axis, there are two directions you can move from the point x equals a. You can move to the right and you can move to the left. And so we're assuming when we say the slope is a certain number, we are talking about if we're moving to the right, the default direction is to the right. But in the situation with two variables, the point negative 2, comma 3 is in the domain. Here's the x-axis, here's the y-axis, here's the point negative 2, comma 3. And there are infinitely many different directions that we can move in from this point. It's not like the x-axis where there's only two directions and we just pick one of them as the default. So we have to specify a direction in the two variable case. If there's two or more variables, then there's infinitely many directions that we could go in from any particular point in the domain. So we have to specify the direction. Okay, so now the formula for finding the derivative in a certain direction, it's the derivative in the direction of a vector of a function at a point AB is the gradient of the function at the point dotted with the vector. So that's our formula. Now it's important here that the vector u is a unit vector. So when they tell us the direction of this vector has both a magnitude and a direction, and we're only interested in the direction, so we should normalize the vector, turn it into a unit vector. So in this particular problem, u is going to be the vector 1 over the magnitude, comma, negative 4 over the magnitude. And the magnitude is the square root of 1 squared plus negative 4 squared, which is the square root of 17. So the unit vector is 1 over the square root of 17, comma, negative 4 over the square root of 17. So that is the vector u that we're going to use in this calculation, not the given vector. Okay, the given vector had to be normalized and turned into a unit vector. Okay, so now the gradient of a function of two variables is the vector f sub x, comma, f sub y. And in this particular instance, f sub x, the derivative of the logarithm is 1 over the inside, and then times the derivative of the inside with respect to x. So we get 2x plus 0, so just 2x. And the same for f sub y, the derivative of the log, 1 over the inside, and then times the derivative of the inside with respect to y. which is 0 plus 2y. So there's our gradient. And now the gradient at the point negative 2 comma 3 is the vector. 2 times negative 2 is negative 4 over negative 2 squared is 4, 3 squared is 9, that's 13. So 13, and here we have 2y is 6 over 13. So this is our gradient, and there's our unit vector. So the derivative, finally, the derivative of our function at the point negative 2 comma 3 is the gradient, negative 4 over 13 comma 6 over 13, dotted with this unit vector. So dot product with 1 over the square root of 17, comma negative 4 over the square root of 17. And this dot product is, multiply the x coordinates, negative 4 over 13 root 17, plus multiply the y coordinates, negative 24 over 13 root 17, and we get altogether negative 28 over 13 root 17. So there is the derivative above the point negative 2 comma 3 and in the direction of the vector 1 comma negative 4.